Hey y'all, Data Guy here. And today I have a video for you where I want to kind of go through best practices for one of the hottest data engineering tools out there, DBT, or the full name, Data Build Tool. So there's a lot of different ways you can architect your DBT scripts, and there's also a lot of hidden features that a lot of people don't take advantage of when they're designing them. They just look at them, hey, this is just templatized SQL scripts that I can run in a sequence. But there's a lot of ways you can actually up-level those DBT workflows to get a lot more out of your DBT jobs, and also have them run more efficiently, make them more dynamic, and save you a whole lot of time and effort fixing things that might go wrong in the future. So that's really what I'm going to cover today is some examples and live real-world examples of how you can optimize your DBT scripts, and then also some more best practices around managing those DBT workflows, the best ways to organize them, deploy them, monitor them, so you can kind of walk out of this video with really an understanding of guidelines for how you should be deploying and using DBT in production. So without further ado, let's get into it. So the first approach and kind of just general best practice that you'll want to implement within DBT is the idea of modularity. And so in this example I have here, you have kind of three different options. So you have your staging orders, you have your intermediate model, which is calculating daily orders, and a final model, which is filtering those orders by status. Now, this approach, instead of having just kind of one big monolithic script that might do everything, sometimes people like to write SQL commands that would incorporate all of this into it. So it's just one command that pulls the orders, calculates those daily orders, and then filters for just the daily orders that have been completed, all in one single operation. However, there's a few reasons why that approach has quite a few disadvantages compared to this more modular approach. Now, first is reusability. By splitting these transformations into separate models, where this first model is in a separate file from the intermediate model, from this final model, so they all act as independent steps within your DBT workflow, you can reuse that logic for different parts of your project. So maybe actually these staging orders that you're pulling out, they might actually be used in many different pipelines. And if you didn't have this broken out into its own separate entity, you would have to just rewrite that same SQL logic in any script that needed to pull the staging orders, rather than have just this kind of Lego building block that you can plug in as the beginning of any pipeline that needs to pull and access that order data. And that way you don't have to, you can then take that second level transformation, calculating daily orders, filtering by status, and build pipelines out of that gold standard that are only change and write code for the parts that are actually changing between those different pipelines. So really simple change, but really improves that reusability. And then also readability and maintenance. Smaller models are obviously easier to understand and maintain, and if each model is performing a specific task, it makes it much easier to locate issues and exactly where they're coming from, as well as understanding kind of the flow of data transformations. For example, the intermediate daily orders step model is only focusing on aggregating orders by day, which means that if this step and model fails, we know that there's some issue with the aggregation of orders by day, and really simplifies that debugging flow of, hey, what went wrong, versus if this is all one monolithic SQL script, it could have been any of these three stages that failed, and I'd have to go there and figure that out. And then finally, the separation of concerns. Each model should handle a distinct aspect of the data processing pipeline, like staging raw data, performing intermediate calculations, and then generating final reports. You can see that broken down here. And this separation really will help you in organizing your project logically, and then also make it easier for your teams to collaborate. Now, the second major tip I have for you is to leverage DBT macros and Jinja templates. So here you can see an example of a DBT macro, which is really just a templatized operation that you can then reference just as calculate date diff. So rather than needing to write this whole logic into every model that needs to calculate the date difference, you define that logic in one place, and then you can use it across all of the models within your DBT project. And then compounding this are Jinja templates, where you can see some of these fields are have those curly brackets around them, which means that you can actually inject at runtime, the first order date, last order date into this macro, so you can change the variables that are being injected into that macro between between DBT pipeline runs as well. And there's a couple of reasons why using them is considered best practices. Number one is the don't repeat yourself principle. So macros really help you to avoid code duplication by encapsulating that repetitive logic in a single place, and then makes that reusable across all of your different models within your project. So, if you need to calculate this date difference, you can define it once and then reuse it through every model that needs it, and also ensures consistency in how that operation occurs across your models. If you're calculating this manually in many different places, the odds are that you might screw it up and not replicate it perfectly in another model are greatly increased. And so maybe you might be calculating the date difference in one pipeline or model differently than how you're doing it in another if you're not using these kind of macros. Secondly, simplified updates. If you one day down the road want to change how you're calculating your date differences, switching to another function, you only need to update that specific macro rather than needing to figure out every piece in your code where you've actually calculated that date difference and then update that logic to replicate your new logic as well. So this is going to really help your code base become a lot more maintainable and much less prone to errors by just reducing the attack vectors by which errors can actually occur. And then finally, much more improved readability. Using macros really helps make your SQL code much more readable by abstracting that complex, just kind of boilerplate logic. And so you don't have your models cluttered with complex calculations. You just have macro calls that kind of abstract away that complex logic. So you just need to understand what that logic is actually doing rather than needing to, figure it out yourself by just reading through and defining it in your own brain. Now, the next best practice I want to talk about is making sure that you are implementing data quality tests into your DBT pipelines. Data quality tests are really integral for ensuring that data is being transformed and analyzed and it's resulting in accurate data that is also reliable, especially across many different model runs. And if you're doing anything with AI and ML, if you have bad data or that data is corrupted, your entire model is corrupted. And so data integrity tests help you avoid that and alert you when your data moves out of your defined values of valid data. And so tests such as unique and not null here, you can see as examples, are examples of best practices data quality tests. So enforcing constraints that are critical for data integrity, making sure that, hey, I have order IDs are all unique, prevent any duplicates, because if there's duplicates, that could lead to some incorrect aggregations and potentially misleading insights. You also have early error detection. So by running tests during the transformation process, you can help catch and address data quality issues before they actually propagate downstream into your database and reduce the risk of that bad data showing up in downstream reports and analytics, and allowing your executives or anyone who's consuming data to have full trust that that data has at least passed a minimum standard for data integrity. Additionally, you can do kind of even more custom tests. So things like this custom SQL test that's making sure that the total orders isn't negative. So a simple check to make sure you don't have an invalid value that might not show up just by a simple data check or uniqueness check. And this level of testing kind of goes beyond those basic tests of not null or is it unique, and actually aligns data quality with specific business needs. You can actually test your data and configure tests that align with exactly what you expect out of your data. And then finally, by integrating your tests directly into your DBT models, you're helping to automate data validation. So these data quality tests will run automatically whenever the models are executed, and this helps to ensure continuous validation and maintaining a high standard of data quality over the long period of time. Now, the next best practice I want to talk about is implementing incremental models. So incremental models, and you can see how to implement here, it's just a simple config operation, but they're really crucial for optimizing performance, especially in production environments that might be handling large data sets. And this is because, number one, efficiency. Incremental models are only going to process new or changed data rather than reprocessing the entire data set. You can set this here, or you can say, hey, select the max order date, only process data after that max order date, which is kept as a variable between model runs, so you can track, hey, only process data that's been propagated since that last model run. And this really helps to reduce the time and computational resources required to run those transformations, because instead of needing to pull out that entire data set, you have an automated check to only bring in new information and process that new information. Also has another downstream effect of making your pipelines much more cost effective by minimizing the amount of data that's processed in each run. So it helps to reduce the load on your data warehouse and translates into lower operational costs, especially in those cloud environments where compute and storage are all based on usage. Then third, we have scalability. So as your data sets grow, full refreshes of data models can become pretty impractical. And so incremental processing allows your pipeline to scale effectively without compromising on performance or data freshness. And then finally, data freshness. Incremental models allow you to make more frequent updates to the transformed data because it only needs to process the new data. And so this makes it really important for environments where near real-time data is required for decision making. So things like dashboards or reporting tools, this allows you to run those queries cheaply enough that you can do it more often. Now, my next bit of best practices that might seem simple, but some people don't know about it, is to leverage the DBT Connection Management system. So you do have a nice little profiles YAML configuration, and I wouldn't put a lot of sensitive data in here, but this is a really great way to have different database profiles you can rapidly switch between, like dev versus prod versus staging, so that you can ensure that, hey, development work, models that are running in development won't impact production data, and you have very clear visibility into, hey, what is this model using? And you can also hot swap between, hey, you go from dev to prod, rather than need to input all that connection details, you just switch that profile and boom, now you're executing that model in dev versus prod. And just generally makes it easier to share, and have different connections connected to a single DBT environment. So really simple best practice. I won't spend too much time on why it's important, because it's obviously important and it's a very useful feature. But highly recommend using it if you aren't already. Just you can reference those connections just a single string rather than need to manually add them, especially if you're using multiple databases within a single DBT project. Now, the final tip I have for you is make sure you're integrating DBT into your CICD pipeline. So here you can see a very simple GitHub Actions workflow I've put together, where you're integrating your DBT workflows into a CI/CD pipeline and just making sure you are testing and have a CI/CD flow set up for iterating and keeping track of iterations on your DBT models. DBT especially is something that if you don't keep track of changes, it can get really messy, especially if you have multiple people working on it. And so having that kind of gold standard, hey, this is what our production DBT environment looks like, but still having the option for developers to branch off and create their own environments is really useful for maintaining a fast speed of iteration, but without compromising the safety of your production environment. So really simple example, but just something that I think a lot of people should do more of and integrate DBT into their CI/CD pipelines rather than just kind of developing independently or testing in prod. God, I hope not, but some people do it. And so just having a good CI/CD pipeline, because then you can revert back to previous version of that DBT project, it's really helpful for keeping your speed of development fast, but also safe. Now, that is all the best practices I have for you today covering DBT. I hope you've learned something. I hope you feel equipped, and I hope you have a great rest of your day. Data Guy out.